This question says, sketch the logarithmic function, label 3 points on the graph, determine the domain and the equation of any vertical asymptotes. Our function is h of x equals log base 6 of x. So we're going to sketch the graph of this logarithmic function by plotting points. And I'm going to rewrite this logarithmic equation as y equals log base 6 of x. And I'm also going to rewrite this equation as an exponential equation. It's much easier to find the ordered pairs when they're written in exponential form versus logarithmic form. So to write this as an exponential, we would write it as 6 to the y equals x. This is using the definition of a logarithm. So now I'm going to make a chart, and this chart is going to have x and y values. Typically, we would choose values for x and find the values for y, but since I've rewritten this equation as 6 to the y equals x, I'm going to choose values for y and find the x. So let's use -2, -1, 0, 1, and 2 as my y's. I'll substitute them into the equation. That's 6 to the -2, 6 to the -1, 6 to the 0, 6 to the 1, and 6 to the 2. We can simplify these. 6 squared is 36. 6 to the first is 6. 6 to the 0 power is 1. 6 to the -1, the -1 in the exponent means reciprocal, so that's 1/6. 6 to the -2, the negative is reciprocal, so that would be 1/36. So this gives me some ordered pairs that I can plot. My ordered pairs are 1/36, -2, 1/6, -1, 1, 0, 6, 1, and 36, 2. So 1/36 and -2 would be 1/36 is really close to 0, right next to 0 with a y value of -2. 1/6 and -1, 1/6 is also pretty close to 0 with a y value of -1. Then we have 1, 0, 6, 1, and 36, 2 would be too far off of my grid to show. I'm going to connect these 4 points. And this is a picture of our log function, y equals log base 6 of x. We also want to determine the domain. If we take a look at our picture, we can see that our graph is only to the right of the y-axis. And our domain will be 0 to infinity. You can also notice that your vertical asymptote will be right on top of the y-axis, which is the vertical line x equals 0. So that's the location of our vertical asymptote. For this question, we are going to use the properties of logarithms to rewrite the given expression as a single logarithm. Whenever possible, we'll evaluate the logarithmic expressions. Our example has natural log of x minus 3 minus natural log of the square root of x plus 1 minus natural log of 2x. So what I've done is I've written out some of the properties that we're going to use to simplify this logarithmic expression. The properties that we're going to use are the product rule for logarithms, the quotient rule for logarithms, and the power rule for logarithms. And in this example, we're trying to condense all of these logarithmic expressions into a single logarithm. And that would be starting with what we have on the right and condensing to what we have on the left. So the product rule is used whenever you have the sum of logs and you condense to the product. You put a product inside your log. The quotient rule is used when you have subtraction, and when you condense with division. And then the power rule is used whenever you have a coefficient that is attached to your log, and you're going to move that coefficient into the power. You can see that p is the coefficient on the right, but it is the power on the left. So these are the properties that we're going to use to simplify this and rewrite it as a single logarithm. So one thing that you need to be sure of is that all of the logarithms have the same base. All of these logarithms say ln, which stands for natural log. And natural log is used when you have the natural base of e. So all of these have the meaning of log base e. So since they have all the same base, we are able to condense this to a single logarithm. And what I'm looking for, starting off, is to see if there are any coefficients. We notice that there are not any coefficients. If there were coefficients, you would need to use the power rule first. But since we don't have any coefficients, we'll move on to looking for either minuses or pluses, and that'll tell you to use either the product rule or the quotient rule. So I can see that I have a minus, and this log here has no sign in front of it, so we assume that it is positive. So that's going to tell us how to condense our logarithm. So because we have some subtractions, we are going to have a fraction inside. This factor of 2x has a negative, so that factor of 2x will go in the denominator. This factor of square root of x plus 1 has a negative, so it will go into the denominator. And then finally, we have this factor of x minus 3, and it's on a positive log, so it will go into the numerator. So this expression condensed using the product and the quotient rule to become natural log of x minus 3 over 2x square root of x plus 1. For this question, we want to find the domain of the logarithmic function f of x equals log base 2 of 5x plus 20. I've got some information on logarithmic functions. We have the definition of a logarithmic function. And what we notice about this logarithmic function is that g of x the expression that is inside the logarithm needs to be a positive value. The log of 0 is undefined, and the log of a negative is undefined. So when we're finding the domain of a logarithm, we want the expression that is inside the log to be positive, because if the expression inside the log is 0, that's undefined, or if it's negative, it's undefined. So to find the domain, we're going to take the expression 5x plus 20, that's the expression inside the log, and we're going to create the inequality greater than 0. 5x plus 20 is greater than 0. We'll solve by subtracting 20 on both sides. That gives 5x is greater than negative 20. Divide by 5 on both sides, and that gives x is greater than negative 4. This solution is the domain of our logarithmic function. So we can mark out on our number line where negative 4 is. We'll mark it with an open circle as to not include it. And numbers that are greater than negative 4 are the numbers to the right of negative 4 on the number line. So we found that the domain of this logarithmic function is from negative 4 to infinity, and that does not include negative 4, and that's why I've used a parenthesis in the notation to indicate that negative 4 is not included in the domain. We want to evaluate the expression without the use of a calculator. The expression we want to evaluate is natural log of 1. Well, I'm not sure what this expression equals, so I'm going to say that it is equal to p. So I have natural log of 1 equal p, and then I'll use the definition of a logarithm to rewrite it as an exponential. And the reason why I do this is I'm much more comfortable thinking in terms of exponentials than logarithms. So if I rewrite this as an exponential, I need to know the base of this logarithm. Natural log, ln is natural log, and the meaning of that is log with the natural base e. So when I see the symbols natural log, ln, the meaning is log base e. So now I know that this is log base e. I can rewrite it as an exponential. That would be e, the base of the log, to the power p. The log always equals the exponent, and so since this log equals p, I've used p as the exponent. And then this expression equals what's inside the log of 1. I've rewritten this using the definition of a log as e to the p equals 1. So e to what power equals 1. And I know that e to the 0 power is equal to 1. And so that tells me that my power will be equal to 0. And since I said that this expression is equal to p, I now have that the natural log of 1 equals 0. On this question, we want to use the power rule to expand the logarithmic expression, and whenever possible, evaluate that logarithmic expression. The expression that we have is log base 4 of square root k. And let's take a reminder of what the power rule for logarithms is. With the power rule, If we have an expression, log base b of m to the p, so we have a power inside of our logarithm, what we're allowed to do is to change that power. Instead of being in the exponent, we can make it become the coefficient of our logarithm. So this is what we want to do with our example. However, if we look at our example, we don't currently have a power inside of our logarithm. We have a square root in our logarithm. So one of the algebra properties that we need to remember is that every radical can be written as a power. So I can rewrite square root of k to be k to the 1/2 power. Now we have a power inside of our logarithm, just like we have in our property here. And because we have a power inside our logarithm, we can use the power rule. And the power rule allows us to take that power of 1/2 and move it to become the coefficient on our logarithm. In other words, multiplied by our logarithm. That's what the coefficient does, is it multiplies. So we've rewritten this expression to become 1/2 log base 4 of k. And that is what the directions asked us to do, to use the power rule to expand the logarithmic expression. Thank you for checking out my videos. Have a great day.